Hey everyone, welcome back, and thank you for joining us again in our next discussion of statistics. And that takes us to our next objective, which would be computing probabilities using the general multiplication rule here. Jumping right into an example again, suppose you draw two cards from a standard 52 card deck. What is the probability that both are hearts? Well, the key word here is we're trying to find the probability that both are hearts. We could translate that to say that we're trying to find the probability that both the first and the second are hearts, and you're welcome for that beautiful artistic heart there. We know that and translates to multiplication for us, and now let's break down these two cards. Well, we think to ourselves, what is the probability that the first card is a heart? This is just like using the classical method. Each card has the same opportunity of being pulled. Since each card is equally likely to occur, we've got 13 hearts out of the entire deck, and we've got 52 cards in the entire deck. Therefore, the probability that the first card is a heart would be 13 over 52. We've addressed that we're multiplying these because of that keyword that is and to us. But now we're saying that we pulled a card. That means these two events are not independent. We are holding one heart. That first card we pulled, if that thing is a heart, that means we only have 12 hearts left. If we only have 12 hearts left in that deck, that means the probability of the second card being a heart would be 12 out of however many cards we have left. Well, since we're holding one heart, that means we only have 51 cards left in the deck. Thus, the probability that the second card is a heart would be 12 over 51. If we multiply those two fractions, we get our probability of approximately 0.0588, and that would be our probability using the general multiplication rule. The key focus here, though, is it wasn't just 13 over 52 times 13 over 52, because when we pulled that first card and we were holding it, it changed the probability of us pulling a heart for the second card. Let's go ahead and jump into another example. Now suppose we decide to play music on our phone using the random feature. It's programmed so that no song will play more than once. We've got 85 songs on our phones. You really only like 25 of them though. What is the probability that you like the first 3 songs that play? Now, of course, this is the key part in the actual question aspect. We're trying to find the probability that you like the first 3 songs that play. We can translate this to be saying we're trying to find the probability that I like the first one and the second one and the third one. Well, just like we did on the previous example, we could think of this in terms of the first and the second and the third songs, address them individually, and figure out their individual probabilities. Taking a look at the first song, you're asking yourself, what is the probability that I like the first song? Well, first we have 85 songs available, just like we had our 52 cards previously. We know that we like 25 of them, and all of them are available to play in this first song. Therefore, the probability that we like the first song would be 25 over 85. Since we know we have the word and in between, we're going to be multiplying these probabilities. Heading to the second song though, we just played the first song, and we're told that no song will play more than once. That means we only have 84 songs that can be played when we listen to this second song, and since we like 25 of them, but one of them already played, that means there are 24 songs left that we can actually like. Continuing with that same logic, now those first 2 songs, the first and the second one, cannot be repeated. Therefore, there are only 83 songs left in our phone that will play, and since we liked the previous one, that means there are only 23 of them that we still like. Therefore, the probability of our third song would be 23 over 83. If we multiply our 3 fractions together, we get a probability of approximately 0.0233, and we found our probability one more time using the general multiplication rule. So yet again, now that we've done a couple examples, it begs the question, what is the general multiplication rule? Well, our general multiplication rule states that the probability of any 2 events E and F, whether they're independent or dependent, the probability that any 2 events E and F occur can be found by taking the probability that event E occurs, that first event, and then multiply that by the probability that F, the second event, occurs, given that the first event has already occurred. Again, just referring to our first example, our event E was our 13 out of 52 cards, that first card that we pulled when we were looking for hearts, and given that the first card was a heart, the probability that event F, the second card, was a heart would be a 12 out of our now 51 because we had one less card. And we have our mathematical general multiplication rule. Heading into another example then, We're told in 2005, 19.1% of all murder victims were between the ages of 20 and 24 years old. This is just like we were told with one of those examples from conditional probabilities. Continuing here, 86.9% of the murder victims that were 20 to 24 years old were also male. Before we get into which one is given, let's go ahead and read the actual question that we're being asked. What is the probability that a randomly selected murder victim in 2005 was a 20 to 24-year-old male? This is the tough part to resist. It may feel like it's very similar to or the same as the previous example with these murder victims. But remember, on that first murder victim example, we were asked what is the probability that a randomly selected murder victim in 2005 was male, given that the victim is 20 to 24 years old. This time, we're asked what is the probability that a randomly selected murder victim. That means we are talking about out of the entire population. They did not give us some sort of condition within the actual question. Therefore, we're talking about all of the murder victims right now. And the question would be, what's the probability that this randomly selected murder victim out of everyone was a 20 to 24-year-old male? As previously discussed, that's a bit sneaky in the way that it's worded. That means we have to recognize that this represents E and F. 20 to 24-year-old male means that we have the age and the gender under discussion here. So if we're looking for the probability of E and F, then we know we have to address which one is E and which one is F. Looking back at the beginning then, we had 86.9% of the murder victims that were 20 to 24 years old. Since they say that were, meaning that part is given, that establishes which aspect is our event E. If we're okay with that, then that means the aspect of gender becomes our event F. So we have male being the event F, age being event E. That means our 19.1% is still the probability of event E, since it's discussing age, and that 86.9% would be the probability of event F given E. It's 86.9% of the murder victims were male, given that they were 20 to 24 years old. So if we're only looking at the 20 to 24-year-old murder victims, 86.9% of them were male. That's a lot to process, but if we've got that part handled, we know we're looking for the probability of E and F. To find the probability of E and F, we take the probability of E and multiply that by the probability of F given E, of course coming from our formula. From the problem, we have our probability of event E at a 0.191 again. The probability of F given E we address as our 86.9%, and that means we get our probability at approximately 0.1660. And that means one more time, we're all set with our probability using the general multiplication rule. Now that does create the key technical question, why did we have to use the general multiplication rule rather than the multiplication rule for independent events that we discussed in a previous section? The answer to that would be, we did not have the information for independent events. Instead, we were only given the percentage of murder victims that were male, given that they were 20 to 24 years old. That was our 86.9%. They told us 86.9% of the murder victims that were 20 to 24 years old were also male. They did not give us the individual probabilities for independent events, thus we had to use the general multiplication rule. And that wraps up our discussion on conditional probability and the general multiplication rule.